Welcome to the Ansys Indy Autonomous Challenge Simulation Race. My name is Tom Smithyman, and I have the pleasure of walking you through this first-of-its-kind challenge. The global economy is undergoing the largest technological transformation in history, and we're just starting to see the benefit from that unprecedented innovation as multiple technologies converge, resulting in disruptive breakthroughs. These innovations, including engineering simulation, are driving massive changes in the transportation and mobility industries, resulting in autonomous and electric vehicles. Once, these breakthroughs were thought to be the stuff of science fiction, but today, with the power of simulation in the hands of some very gifted university teams, they are becoming reality. Energy Systems Network, in close collaboration with the Indianapolis Motor Speedway, has created this challenge for university teams to innovate and race fully autonomous vehicles head-to-head at speeds of up to 180 miles per hour around the famed Indianapolis track on October 23rd, 2021. Before the teams can race on the actual circuit, though, they must first demonstrate the performance of their race car controllers in the virtual world at today's Ansys Indy Autonomous Challenge Simulation Race. The teams must navigate a fine line between executing bold maneuvers to remain competitive and ensuring safety and compliance with the race rules. With a dynamically evolving situation on the track, the teams must optimize their race strategies in real time. And to challenge the teams even further, we've thrown in some real-world racing conditions for them to consider, like tire degradation. Now, before we get to the race itself, let's hear from Matt Peak, Managing Director of Energy Systems Network.
The potential for autonomous vehicles is undeniable, but there's really significant obstacles for autonomous vehicles to become a reality in our daily lives. My name is Matt Peak. I'm Managing Director of Energy Systems Network. We partnered with the Indianapolis Motor Speedway to launch the Indy Autonomous Challenge, a competition to design software that controls autonomous race cars to compete head-to-head in an all-out race at the Indianapolis Motor Speedway. Simulation is what enables these students to design the sorts of software that they're going to be running in the real race cars. It gives them the freedom to be creative in the way that they think about solving what's a very complex problem. There's no better company in the world to partner on this effort than Ansys. We wouldn't have been able to get here without their unique contribution of talent, support, time, interest, and passion for everything that we're doing.
Thanks, Matt. Now let's head to our time trials at the virtual Indianapolis Motor Speedway track. The results will determine our starting order in the semifinals. These virtual drivers have their work cut out for them as they try to interpret data from 5 cameras, 4 radars, and 3 lidars. As each of the cars get their rolling starts, let's head to the track, where we'll find our commentators, Shubhang Mittal and Ryan Gillerin, who are waiting to call the action.
Thanks, Tom. It's going to be a great day out on the virtual racetrack today. Before we begin our time trials, let's take a look at the 16 teams that will be racing today, each jockeying for the best starting position within the semifinals.
It has taken a lot of work to advance this far in the competition. Over the past year, the teams have competed in a series of 3 hackathons that have challenged them to progressively improve their algorithms through simulation.
Today's simulation race is an important milestone for these university race teams. The prediction, planning, and control algorithms that they've developed will be tested in a dynamic, high-speed racing environment, which is sure to be exciting.
The progress the teams have made today to get to this point is phenomenal, and no doubt the experience gained today will help these teams continue to progress their technology and race tactics. So let's go racing. We will run the time trials in reverse order by team number, so the first team out is Waterloo Autonomous Racing, Water Race for short, from the University of Waterloo, Canada.
Water Race placed 4th in the previous hackathon and took home the Rising Star Award in the process. Let's see if they can continue to build off that strong performance and step onto the podium this time around.
And we have our first time on the board. Time is 51.984. That's a huge improvement from the practice heats.
Next up, we have Ariel team hailing from Ariel University, Israel, which is home to many exciting mobility startups. This team has a ton of experience with developing advanced algorithms for high-performance autonomous vehicles. They put together a strong run in last hackathon, but ultimately ended up placing in 6th. They've got to be itching to get back out there and continue their ascent to the top of the leaderboard.
And we have a time of 51.968, narrowly beating out Water Race by less than 0.02 of a second.
We have WUT driverless from Warsaw University of Technology, or WUT for short, out on the track. This team is located in Poland and has a history of leading a variety of autonomous and robotics competitions, securing the top spots in the International Autonomous Robot Racing Competition and the Corolla Cup. With the Indy Autonomous Challenge, the team is looking to leverage their past experiences on the racetrack.
Time posted by WUT is 51.888. That looks like a tough time to beat. They're taking the top spot for now.
Up next is Cavalier Autonomous Racing from the University of Virginia. There's a popular saying in racing that if everything seems under control, you're not going fast enough, and this team lives by that motto. They're always pushing the envelope with a very unique approach to development, building upon their F1 10th racing testbed. Let's see how they scale their experience to a virtual Dallara AV21 race car.
They're not able to make it into the 51s, posting a time of 52.008. Let's not write them off just yet and see what the other teams have to offer.
Up next on the track is AI Racing Tech. This team out of the University of Hawaii had a bit of a slump in Hackathon 3 compared to Hackathon 2, but it looks like they're going to come back strong. The team is backed by their local tech community in Maui, and if they pull out a victory at the track today, I'm sure they'll be looking forward to the luau that follows back home.
Time posted is 51.952, beating out Aerial Team but short of the mark set by WUT driverless.
Up next is Autonomous Tiger Racing out of Auburn University in Alabama. This team has been one of the front runners right from the start of this challenge, finishing third in the 2 previous hackathons. I know they desperately want to advance to the next stage so they have a chance to take home some more shiny medals.
Looks like they've brought the pace to prove that, and we have a new chart topper at 51.880. Exciting stuff by Autonomous Tiger Racing.
Black and Gold Autonomous Racing is a collaboration between Purdue University and the United States Military Academy at West Point. These two schools, working together across the USA from Indiana and New York, bring unique experiences to the table and are developing their trajectory by studying race lines by professional motorsports racers. Their hope is that their combined experience and expertise will lead them to victory here today.
Posting a time of 51.920. It's an excellent time, but seems like Autonomous Tiger Racing will be holding on to the top spot for now.
Pegasus and RIT Autonomous Racing are next on the track. This race car controller is a collaboration between two teams. Pegasus from Colorado State University and Western Michigan University, who are working with RIT from Rochester Institute of Technology in New York. Together they bring a diverse mix of talent with a common goal to address the complexities of this challenge.
Posting a time of 56.632. Let's hope they'll make up some positions in the semifinals.
Up next is Revelry Racing. They finished in the middle of the pack in both Hackathons 2 and 3. This team from Texas A&M University previously built algorithms to address the complexity of rural driving conditions for self-driving cars. Let's see if they can adapt their algorithms for rural roadways over to the roaring raceway.
Posting a time of 52.152. They beat Pegasus RIT but have to make up some of those positions in the upcoming heats.
Next up is TUM Autonomous Motorsports, who did drop a few places in Hackathon 3 after just missing the podium in Hackathon 2. Seems like they're bringing their A-game here though. The team from Technical University of Munich, Germany evaluates their performance and builds race strategies using their unique hardware-in-the-loop simulator, giving them an edge when it's time to deploy their virtual driver out on the real track.
51.928, slotting in between Black and Gold and AI Racing Tech. That's a really good position to be in.
Up next is KAIST. Hailing from Korea Advanced Institute of Science and Technology, South Korea, this team previously won the inaugural IROS Autonomous Drone Racing Competition. They're a fierce competitor and will be looking to place on the podium in this challenge too, placing 5th and 7th in the 2nd and 3rd hackathons.
With a time of 51.992, they place themselves in the middle of the grid, slotting in right behind Water Race.
Next on the track is Team Euro Racing. Euro Racing is a collaboration of teams from 4 universities across Italy, Switzerland, and Poland. Each university brings their own unique experience in the autonomous space and are now coming together to take on the Indy Autonomous Challenge.
Euro Racing looks like they're skirting the track bounce there. The stewards are going to have to look into that one. They post a time of 51.880 without penalties for now, matching Autonomous Tiger Racing.
Up next is MITPIT, a collaboration between Massachusetts Institute of Technology and the University of Pittsburgh in Pennsylvania. Both of these schools have a rich history in robotics and have quickly become a team to watch out for as they're setting their sights on autonomous racing. Team members finished on the podium in both the Formula Student Driverless Series and the Autonomous Vehicle Challenge, their first cracks at autonomous racing competition.
And posting a time of 52 even, they slot in between KAIST and Cavalier for 9th place.
Crimson Autonomous Racing from the University of Alabama is up next. The team is also participating in competitions like the Eco Car Mobility Challenge and Formula Student competitions. They placed second in Hackathon 2, but managed to snatch the crown from Polymove in Hackathon 3. Can they retain their place at the top?
A few ways off from the top spot, posting an identical time to Cavalier of 52.008. Cavalier is going to take the lead here as they submitted the virtual controller ahead of Crimson.
IUPUI, IIT, KGP, USB is out on the track now. This team is a unique collaboration between universities from 3 different continents. Indiana University, Purdue University in Indianapolis out of the US, and teams from Colombia, South America, and India. We have to commend this team. I mean, imagine having to collaborate across 3 different time zones.
IUPUI making contact with the wall there, that's going to be an expensive penalty. Posting a time of 53.616, the impending penalty might hurt their time even further.
Finally on the track, we have Polymove. This team has been a force to be reckoned with ever since the start of this challenge. Let's just say the podium is like a second home to this team, after winning Hackathon 2 and finishing as a runner-up in Hackathon 3. Polymove will look to get revenge here today and restake their claim as a top Indy Autonomous Challenge contender.
And it looks like they're back with a vengeance, posting the best time of the evening, 51.848. They have managed to carve out 3/100ths of a second from Autonomous Tiger Racing.
Over to you, Tom, to give us a roundup of all the time trials, and more importantly, tell us what the race stewards have to say about the incidents on the track.
What an amazing performance by Polymove, who posted that perfect lap, which puts them at the top of the grid. Unfortunately, though, Euro Racing has received a penalty for exceeding track bounds, and IUPUI lands a penalty for having a minor collision with the wall. All teams have proven that they have the pace. They're all within a second of the leader, which means we're going to have an exciting race ahead. Now, on to the next round, where the teams transition from being the only car on the track to considering other competitors. That means the teams must demonstrate safe operation. It's a balancing act between speed and safety. Now let's look at some of the incidents from the practice starts.
The time trial results had shown that the teams had optimized their racing lines to maximize speed. But it will take more than speed to win this race. In this next phase, teams participate in a series of practice race starts to demonstrate their ability to safely interact with the other vehicles in close quarters.
Teams are required to demonstrate situational awareness and to incorporate collision avoidance, especially when performing overtaking maneuvers. To replicate the serious consequences that may occur with physical race cars, a crash during this phase would be the end of the road for the team.
One benefit with this simulation race is that the penalties may only be assigned to teams that are evaluated to be at fault for an incident. Vehicle-to-vehicle interactions aren't modeled, so collisions will be evaluated by a panel of 3 race stewards who are keeping an eye out for overlap between race cars.
With that introduction, let's begin. Cavalier makes a move to pass Geist on the outside heading into turn 1, but they make a premature move to the inside leading to a collision, while the rest of the field pulls away. On the next start, Black and Gold making an aggressive move to the inside, but they lose control and spin out in the process.
Further back in the grid, we have another incident as Pegasus RIT drives into the back of Mid Pit, who has slow start. Number 13, Autonomous Tiger Racing, starts on pole position and makes an unconventional move to the outside where they run into AI Racing Tech. AI Racing corrects a bit late and goes into a spin, but Autonomous Tiger Racing is found to be at fault here, and AI Racing will move on to the next round. Water Race is going into turn 2, carrying some speed behind AI Racing, looking for a gap to the inside, but their window closes and they collide as they try to move back to the outside.
In the same practice race, IUPUI, car number 3, has some struggles as they clip mid-pit during an overtake. Then, on the front straight, they drift off course and crash into the wall. This is going to take them out of the race.
That will bring us to the end of the validation rounds. We can see the challenges the teams face balancing their desire to follow their preferred racing line while maneuvering around other autonomous vehicles that are on different lines. Over to you, Tom, in the studio for the roundup.
As we conclude the time trials, 10 teams have made it to the next round. The advancing teams are split into 2 groups for these semifinals based on the order that they finished in the original time trials. For the first semifinal, we have Polymove, TUM, Ariel, Mitpit, and Reveille Racing. Now, back to Shubhang and Ryan.
And we're all set up in the Ansys Autonomy Simulator for the first semi-final. Our 100km/h rolling start is clean as the cars accelerate away. Polymove making the move to the outside to fend off TUM and quickly back on the inside. There's a slow start there by Midpit. That was an interesting start. Here is a view from the LiDAR on aerial team in the middle of the pack. The LiDAR gives precise distance measurements showing features of other vehicles, but notice the dark shadows in the point cloud due to occlusions. For the semi-final heats, we are introducing a new controller view on the right. This view shows actuator command values produced by the race car algorithms. Here you can see the team name, steering angle, throttle, and brake percent over bounding box for each car. TUM managing to hold on to second place there as they head into the first corner. A missed opportunity by Ariel as they could have used the draft from Polymove to get ahead.
Ariel seems to be falling back already. Hopefully they'll be able to catch up with a full race length to go. TUM is not holding back though. They're taking the fight to Polymove early in this one.
Not many position changes there after the race start, but TUM, it looks like they're onto something, catching the toe from Polymove on that long back straight. And they make a bold maneuver to the outside into turn 3, but Polymove holding on to that dear first place.
Hopefully in future laps, the virtual driver positions itself on the inside to use that momentum at the end of that long straight.
What a great start to the semifinals. Polymove continued its dominance by maintaining its lead throughout the 10 laps. Ariel put up quite a battle to try to take that number 2 spot from TUM, but TUM was able to fend them off. Pit never recovered from their slow start off the line, dropping to 5th, and Reveille Racing took full advantage of the situation and raced up to 4th place. Now, let's move to the second semifinals, which pits WUT driverless, AI Racing Tech, Keist, Crimson Autonomous Racing, and Euro Racing against each other. Back to Shabong and Ryan.
All right, everybody, it's time for semifinal 2. We have 5 cars on the grid, and they are off. It's a clean start as vehicles head into turn 1. Euro Racing taking a really aggressive line into turn 1, getting really close to Crimson. Do you think they made contact, Shubham?
Let's take a look at it from a different angle. The race towards have a few incidents to report as well. Euro Racing making contact with Crimson as they move to the inside. And it doesn't end there. Keist getting rear-ended both by Euro Racing and Crimson. The race has to be stopped so the incidents can be reviewed. In the meantime, let's jump to an on-vehicle sensor view. Here is the LiDAR sensor data from Keist looking rearwards. In this view, we see Keist exiting the front straightaway and pulling ahead into turn 1. But exiting turn 1, Euro Racing and Crimson close the gap and collide with Keist.
We have a number of incidents on the first lap which have forced a red flag. Euro Racing tried to make up for its poor starting position, but clipped Crimson's car. That drew a minor penalty. Then Euro Racing drove into the back of Keist. The race stewards have decided to disqualify Euro Racing on the grounds of safety. And then Keist was rear-ended again, this time by Crimson. Our race stewards have also decided to disqualify Crimson from the race. With the grid again set up, Ryan and Shubong will take us away.
And we're down to 3 cars on the grid for the semifinal 2 restart. And we're off. WUT moving to the outside, keeping AI Racing Tech at bay. Keist following closely behind. Keist keeping up with AI Racing Tech, hoping to move up to the second row in the final grid lineup. AI Racing finds the pace and puts some distance between them.
And we're at the end of the first lap. The timings are in. WUT posting a scorching 54.1 while AI Racing is 0.3 of a second behind them. It's not looking good for Keist. They lose control at the apex of the first turn and are not able to recover. They drop straight into the barriers.
With 2 teams remaining on the grid, the big question is, will AI Racing Tech be able to get past WUT to lock the front row with Polymove?
They seem to be using the full width of the track at the back straight, slotting right behind WUT into turn 3.
WUT taking a wide exit from turn 3, but they know how to block off that opportunity as they move back to the inside into turn 4.
This is their chance. AI Racing positioned perfectly on the start-finish straight. The virtual driver needs to be bold to make a move on the inside, but they're unable to find the pace.
And we're now on lap 3. It's a relentless effort by AI Racing Tech. Do we know how far behind AI Racing Tech is?
AI Racing Tech making up for that gap in lap 2, a full 0.4 of a second faster than WUT. All they need now is a clean overtake maneuver.
WUT holding a strong line. They leave no margin of error that AI Racing can exploit. And they're across the line. What a semifinal heat.
That was a nasty crash for Keist out of turn 1. It looks like they lost control of the vehicle, but since Keist was at the end of the lineup, the race was allowed to continue. At this point, only the 2 remaining teams from the second semifinal will head to the final, with WUT locking in a spot in the front row. Our starting order for the finals has been determined by a combination of their finishing positions in the semifinal. First in both races are in the first row, the second place are in the second row, and so on. And in each row, the team that finished ahead in the time trial gets the preferred inside line. And now, back to Ryan and Shubhang, who will call our final race between Polymove, WUT Driverless, TUM Autonomous Motorsport, AI Racing Tech, Aerial Team, Reveille Racing, and MitPit.
This is the moment we all have been waiting for. We have our 7 contenders in the finals of the Ansys Indy Autonomous Challenge simulation race. Let's go to the track for an exciting race between these top teams.
And we're all set for the finals. We're starting with a 7-car grid. Strong start by Polymove. TUM and WUT battle it out for second. Let's take another look at that start.
TUM's virtual driver taking a strategic approach here, keeping WUT at bay as they battle the lack of tow and concede the position to TUM.
Starting from the second row definitely has its perk. Aerial now making a move on AI Racing, moving up. And it doesn't end there. They're taking a stab at WUT as well.
Yeah, it's not looking good for WUT as they drop from second to fourth in lap 1. Aerial's virtual driver is trying to make up its mind and looking for an opportunity on either side of TUM. Let's take a look at what's happening further back in the grid. Reveille Racing making a move on AI Racing Tech.
Showing some aggression there as they try to keep AI Racing Tech at bay. Reveille Racing slowly creeping up and taking 5th place. AI Racing does not seem too happy about that as they get boxed in on the outside line. Try to move to the inside, getting really close to Reveille Racing. And as they move to the inside, oh, and they crash and they come together.
The race has been stopped by the race stewards to investigate the collision.
AI Racing's virtual driver was a bit too eager to get to that inside line and collided with Reveille Racing. With Reveille setting up for the corner from the inside, it's AI Racing's responsibility to execute a clean pass. The race stewards have decided to disqualify AI Racing Tech and restart the race. Now, the teams had already completed a majority of the first lap when the incident occurred, so this means the race will be restarted with 9 laps to go. There was a lot of action in this first lap, and in the new grid lineup, WUT drops from 2nd to 4th, while TUM and Aerial move up to 2nd and 3rd places respectively. We now have a 6-car grid for the final. Back to Shubhang and Ryan.
And we're back for the Indy Autonomous Challenge Simulation Race Final. A big shake-up on the grid and we're off. TUM contends with the same challenges as WUT from the previous heat. Polymove making it even harder this time, going wide into turn 1.
Aerial with a botched start as TUM seems to have taken the tow from Polymove, and WT getting in on that action as well to grab 3rd.
Aerial team prioritizes safety over retaining position. Let's review the LiDAR point cloud for this event. When TUM makes a sharp move to the inside, Aerial team applies the brakes to avoid a collision, letting WUT slide by on the outside. Over at the back, MitPit staying away from the back.
Back over at the front, WUT making their way ahead of TUM. Moving into 2nd place, TUM not willing to let go that easy though, positioning themselves on the inside as WT goes wide at the back straight. Close quarters racing here in a sprint for P2 as WT and TUM fight it out. TUM coming back out ahead as the car enters turn 4. And we're now on lap 3 as things are starting to heat up. WT's virtual driver has found a gap to get ahead as TUM takes the wider outside line on the straights. They're now slotting in behind Polymove, trying to find a tow. WT moves to the outside. They make the same mistake as they did on the start-finish straight, leaving an open window for TUM on the inside.
And we're on to lap 4, 3 abreast. Polymove elegantly staying ahead. TUM making its intentions known as they try to fend off WT into turn 1 and establish their line. And look at that, we have a new contender in the mix. Aerial sneaking into the battle for 2nd. The virtual driver looking for a tow, replicating the trajectory of TUM as they take 3rd place. WT trying to make up that position using the tow from Aerial. And we're onto the start-finish straight, and we have Polymove, TUM, Aerial, WUT as we're heading into lap 5.
We're at the halfway point of this race now. We have Polymove at the lead, followed by TUM, Aerial, WUT, Reveille Racing, and finally Mid-Pit.
Aerial doing an amazing job of making up positions after a shaky start as we head into lap 6. Well, almost. WUT trying to get ahead as they get a tow from TUM.
Aerial's not giving up just yet. They're looking for an opportunity on the inside. Trying to make a pass. Oh no. It seems like Aerial's virtual driver got spooked there, making its way onto the grass and spinning out. I wonder if the race stewards are going to hold WUT accountable for this one.
And with no cars directly affected, the race moves forward.
With the battle for second down from 3 teams to 2. WUT seems determined, getting ahead to second place, now tailing Polymove closely. They're taking their shot, moving to the outside at the exit of turn 4.
It might be premature as they leave the drafting zone. It's opened up an opportunity for TUM. TUM taking the inside line as they're holding on to this one.
WUT has to quickly make up for that loss to be in contention for second place.
And we're approaching the final lap of the simulation race final. TUM using every inch of the track into turn 1. WUT cutting wide, and looks like there was contact.
Are you sure there was contact, Shubham? We're going to need to look at that top-down view. Oh, you're right. I definitely see some contact there.
The race stewards have their work cut out for them as we're on to the closing lap of this race.
I think WUT might be at fault here. I mean, they made a sudden move to the outside.
But TUM might not be completely off the hook either. They were, in fact, moving to the inside, setting up for the corner.
Quick look at the last 2 contenders as it's time for the checkered flag. Let's look at the finishers as they cross the line. Polymove in first, followed by TUM and WUT, with Reveille Racing and Mid-Pit closing out the top 5. Wow, what an incredible finish, and what a race by Polymove as they led the pack from start to finish and will take home the win. The big question is, how will the race stewards handle that collision between WUT and TUM? It certainly will shake things up for second place where we have 3 contenders. There's only one person the race stewards will want to talk to. Over to you, Tom.
Wow, what an exciting final race. Polymove really showed what a flawless run looks like. They set the top time in the trials and held the lead from start to finish in the semifinals and the finals. But the real fun and the drama was the 3-way battle for second place. WUT, TUM, and Aerial were constantly battling for that coveted spot, which led to a few incidents on the racetrack. WUT moved to the inside, but gave Aerial sufficient space. This scared Aerial's AI driver, though, causing Aerial to spin out into the grass. Now, our race stewards had a long discussion about this one and determined that WUT was not at fault. The bigger question now is the incident between WUT and TUM in the battle for second. And here's what the race stewards have concluded. WUT tried to move to the outside and clipped the back of TUM in the process. WUT initiated the contact and holds responsibility, which results in disqualification for WUT. What a race! You have just witnessed the first part of an epic showdown among university teams from around the world. These teams have leveraged Ansys simulation technology to train the artificial intelligence controlling their virtual race cars in a safe development environment. This enabled them to simulate miles and miles of race car testing across numerous track scenarios, developing algorithms to transform raw sensor data into a winning race strategy. This was a true test of the team's engineering skills, ingenuity, drive, and passion for winning. Now, I am proud to announce that the winner of the $100,000 purse is Polymove from the Politecnico di Milano. Coming in second place and collecting the $50,000 prize is TUM Autonomous Motorsport from the Technical University of Munich. Congratulations to these winners and to all the teams who participated in this first-of-its-kind challenge. However, it's not over yet. The teams must now take what they've learned in this virtual sandbox and apply it to real-world racing conditions that they'll face on the actual Indianapolis Motor Speedway on October 23rd, 2021. Given the magnitude of this challenge, simulation is the only way that engineers can exponentially innovate and solve the most critical AV design challenges, such as system definition, sensor and hardware development, scenario creation, software development, and overall system validation.
Using Ansys, the teams can perform racing simulations across countless scenarios, rapidly and cost-effectively empowering them to develop and to improve their race controllers in a safe, virtual environment. Simply put, simulation is critical for these teams to be ready in time for the physical race.
From this challenge, university teams will push the boundaries of their imaginations and develop the engineering skills that will be the foundation of their learning and innovation journeys. Ultimately, they will become leaders and innovators in their fields, building a more sustainable world for future generations. And behind it all will be Ansys Simulation Solutions, delivering the future of transportation and mobility.